Okay, I think we're actually going here now. So our goal for today then is to be able to write functions representing translations, reflections, stretches, and shrinks of linear and absolute value functions. Okay, so yesterday we had kind of a focus on being able to recognize what had been done. You know, like if this is, here's the parent function, here's the new one, what changed? Did it move up or down, left or right, stretch, flipped, whatever? And today we're going to have a little bit more of a focus on, okay, here's the function we're starting with. It might be a parent function, it might be something else, and I want to do this transformation to it so you write the new equation for me. Not just identifying, but actually you come up with what the new equation is going to be. Okay? And like I said, we're just going to focus on linear and absolute value today with that. Okay? So what I want to do with that is, let's go back to the translation stuff here for just a minute. And we're going to generalize just a little bit. Okay, so let's see what we remember from yesterday with this. So let's say I want to take some function, could be a parent function, some other one. I want to move it up or down. So how do I change the equation to take a function and move it up or down? What did we talk about yesterday? Yeah. You're going to add or subtract, okay, on the end of it, right? So whatever you have, you add or subtract something to the end of it, okay? So a way to write that then is, if you're going to do a vertical translation, which is what we were just talking about there. Yes. I do. Is this a request from another teacher or just? Oh, for my class? Yeah. Yeah, that's fine. We don't have a ton, so we're trying to keep these within the department, but that's fine.
Thank you.
Mm-hmm. Okay, so translation. So if we have y equals f of x plus k, I'm writing this in a different way. Yesterday we just used a bunch of examples to kind of get the ball rolling. With this one, basically what this is that this would be the old function, whatever it is. I'm just calling it f of x right now, but it could be anything. Oops. So old function. And then, like we said, you just add something to it at the end, and that's the k. And that would be the translation. And in this case, it's vertical. Okay, so quick example with that. Kind of like we were doing yesterday. So let's say I have f of x equals, and we'll make it a linear function, 3x minus 1. Okay, so it's not the parent function for linear. That would just be x, right? F of x equals x. But I'm starting off with some random linear function, 3x minus 1. And let's say I want to take that one, and I want to move it, I want to translate it up 5. And rewrite that equation for what that would be if I took that thing and moved it up 5. Okay? So I would have to take f of x, which is 3x minus 1. Okay, that's my f of x for this one. And then I have to add whatever the translation is to the end of that. Okay? So that equation, 3x minus 1, I would then do a plus 5 to the end of that equation that I started with. Okay? And then, from there, there's a little algebra involved. I just got to simplify that equation now. Okay? So if I have 3x minus 1 plus 5, what do I end up with then? 3x plus 4. Right. And so that would be the equation of that f of x moved up 5. Okay? And just remember from yesterday, same thing. If I want to move it down, I would just subtract whatever the number is, Same process, okay? And you can rewrite the equation that way. Okay, so that's doing vertical. Another horizontal translations would be like this. So remember we talked about that whole inside-outside business? Okay, so this would be your translation this time, except horizontal. And notice how I had a minus sign written in there this time instead of a plus sign? That's to remind you that it's the opposite of what you would expect. Okay? So, for this one, let's do a quick example again. So let's say we'll do an absolute value function this time since that's the other thing that we're talking about here. So let's say I'm starting with the function absolute value of x minus 3. Okay? And I want to translate its left 2. Okay, so if it's a left or right movement, I have to do that on the inside. So that's why it's f of, in parentheses, x minus h, showing you that you're not tacking this onto the end of it. It's in the inside of the function then. Okay, so what would my equation become then if I want to take that thing and move it to the left 2? How would that look? Yeah.
Would it be like the absolute value of x minus 3, or would it be like just like?
Well, I gotta do the 2 somehow though. What's gonna go left 2? So where would that 2 go? I guess is essentially what I'm asking then. Oh, no, go ahead. That's fine. We don't multiply it though. Okay, you're close though. Yeah. And what would it look like exactly? You're closer. Not quite there yet. Yeah.
Put it in the center of the absolute value and then add 2.
It would be plus 2. Yeah. So it would look like y equals absolute value of x plus 2. And then we still got that minus 3 on the end, right? Because that was part of the original equation we started with. Okay? So I'm taking this, all right, on the inside, I'm going to do a plus 2 with the x. Okay? Do you guys see the difference between those two again? Kind of like what we talked about yesterday. All right? So, and again, it's always the opposite when it's on the inside, right? The left and right translations are the opposite sign. So if I want to move it to the left, I actually have to put a plus 2 on the inside, not a minus 2. So that's what that would look like. Okay, now, when you get into some linear ones with this left and right translation stuff, sometimes it can be just a little bit confusing. So I want to make a little bit of note, a little note about the horizontal stuff. So with horizontal translations, what you're really doing is you replace x with x minus h. Okay? So think about that for a second. Do you see from this equation to this one, do you see how I left everything else about the equation the same, but I replaced x with x minus h? In this case, it was x plus 2. So I replaced x, got rid of the x, made it x plus 2 instead. Okay? So with any one of those that are horizontal, back and forth, left and right, you want to think about it that way. It's like a substitution. That's exactly what it is, actually. It's a substitution. So let's try this with linear, because with linear, sometimes it can be a little confusing. But if you remember this fact, I think it helps. So let's say I have a function f of x equals 1/2 x plus 4. Let's say that's what I'm starting with. And I want to move this, I want to translate, let's go to the right this time. To the right, 6. When you're starting with a linear function, there isn't necessarily this like inside versus outside thing anymore, right? There's no parentheses or anything like that for you to help you with that. So we want to look at replacing the x with x minus h. Okay? So I'm moving to the right. So what is my x minus h this time for this one? Yep.
So half x minus 6.
Okay, so you answered more than I wanted, but just so instead of x, it's going to be x minus 6, right? Because we're moving it to the right, so it's going to be a minus, so it's minus 6. Okay, so think about taking just the x and making a substitution, changing that x to x minus 6. So it's going to become y equals 1/2 x minus 6 plus 4. So everybody see what I did there? Okay. I did a substitution. I substituted x with x minus 6. All right. And again, from there, now we got a little bit of simplification to do, a little algebra. I got to distribute that 1/2, combine my like terms, do all of that kind of stuff. So if I work that out, y equals 1/2 x. What's 1/2 times 6? 3. Okay, so 1/2 x minus 3 plus 4. So minus 3 plus 4 is plus 1. So that one would actually be 1/2 x plus 1 by the time we're done. Okay, so that's the idea with these translations, okay? The vertical ones are pretty easy. You just tack the number on the end of the thing and then simplify it up. If it's horizontal, you want to think like a substitution, and that's really going to help you, okay? So, any questions on this stuff so far? Doing that? All right. So, let's talk a little bit about some reflections then. Get back into those. We talked about one kind of reflection yesterday, but there was one we didn't. The type of reflection we talked about yesterday was doing a reflection over the x-axis, right? But we can also reflect stuff around the y-axis too. Okay, it's just a different way of doing that. So, y equals negative f of x. That's what we did yesterday. Okay, and we took the existing function f of x, whatever it was, and we just put a negative in front of it, and that reflected it over the x-axis. So if we want to reflect it over the y-axis, it looks like that, f of negative x. So instead of making the entire equation negative, it's just the x becomes negative. And again, we're going to want to think like a substitution again, like we did with the horizontal translations. Okay, so let's practice this a little bit. We'll do one of each here. So let's say my starting function, we'll go back to an absolute value one here again. So let's say our starting equation is f of x equals the absolute value of x minus 3 plus 2. And I want to reflect over the x-axis. So that means take that entire equation and just stick a negative in front of it. Okay? But you have to be a little careful, though, because it's not just a negative in front right here. It's the entire thing is negative. So it's going to look something like this. It's going to be y equals negative. And then just to kind of show you what I'm talking about, I'm going to make some parentheses here. So it's that entire equation, not just the first little piece of it, but the whole thing, negative in front of it. And by writing it this way, then it makes it obvious what we got to do. Well, what do I have to do with that negative? Distribute it. Right. Okay. So it's going to be probably a little bit different than if you had just stuck the negative in front of the absolute value sign there. So the final answer for this one is that. Negative absolute value of x minus 3 minus 2. Okay, so does that make sense why you get the negative showing up in both places there then? Okay. All right, let's try one where we do it over the y-axis and show you what that looks like real quick here. So we'll go back and do a linear function here. So let's say we've got 4x plus 5. And I want to reflect over the y-axis. Okay, so I'm not putting a negative in front of the whole equation like I did with over the x-axis. It's only the x. So think about substitution again. I'm going to take every x that I see in that equation, and I'm going to substitute a negative x in place of it. Okay? So it's going to look something like this then. So y equals 4, and then instead of just x, it's going to be negative x plus 5. Okay, so do you guys see the difference in the strategies there for those? One, it's the whole thing in parentheses, negative in front. The other one, it's just the little x that's made negative. Okay, and that's going to change how that goes. So this final equation then, once I simplify, 4 times negative x, negative 4x, right? And then I still got the plus 5. So that would be the final equation for that thing reflected over the y-axis then. All right, so the basic strategies for reflections, are we feeling okay with those for right now? I want to give you guys a chance to practice these in a little bit, but as long as it makes sense on the outset, I think we're good. So, all right, so we've got the translations, the reflections, and then the last thing that we talked about yesterday that we're going to come back to here today with these is doing this whole stretch and shrink business. All right, so there's more to this story too. So a vertical stretch or shrink and that's the kind we did yesterday. Remember what we just took a number and multiplied it in front? So if your parent function was like x and you had 2x, that meant it had a vertical stretch of 2 to that parent function. So it's just taking some number and multiplying it in front of the whole thing. All right. Now, technically, it could be a stretch. It could be a shrink. There are ways to make these things shrink as well. Okay. So here's how you can tell the difference. If A is greater than 1, like 2, 3, 4, whatever, those are all stretches. And if a is less than 1, then it makes it a shrink. Okay, so if you saw something like y equals 1/2 x, that technically would be a vertical shrink of y equals x. Okay, so it's all about how big that number is. And think about, I don't know how much you guys remember from geometry with, you guys remember doing dilations in geometry? Maybe vaguely, all right? Or scale factor, something else related to dilations, okay? So, or just think about multiplication in general. If you multiply something by a number bigger than 1, what happens to the number? Does it get bigger or smaller? It gets bigger. Okay? If you multiply by something bigger than 1, you get a bigger answer at the end, right? If you multiply something by a number smaller than 1, what happens? It gets smaller, right? Same kind of idea, right? If you want something to stretch, to get bigger, the number has to be bigger than 1. If you want something to shrink or get smaller, the number has to be smaller than 1. What do you suppose happens if you multiply it by exactly 1? Stays the same, doesn't change, right? Just like if you multiply any number by 1, it doesn't change the number, right? The result's still exactly what you started with, okay? That works the same way with this, okay? So, do a quick example of that. So let's say I want to start with, we'll do the absolute value of x plus 3, and I want to do a vertical stretch 4 to that thing. Okay, so if it's going to stretch by 4, then that just means I need to take that equation and put a 4 in front, just like we were talking about yesterday. Okay? Multiply the entire equation by whatever that number is to make it stretch. Okay, so those are the easy ones. If I wanted to make it shrink, let's try a linear one this time. So maybe 6x plus 8, and I want a vertical shrink by 1/2. Okay, that's how you write those out. If it's a stretch, it's going to be a whole number. If it's a shrink, it's going to need to be some kind of little fraction then, right? Because it's got to be something less than 1. The same basic idea, though. You take the 1/2, you multiply the entire thing by 1/2 then. So we would have y equals 1/2 times the entire equation. So it's got to be in parentheses there again. And then with these, you got a little bit of algebra to do. You got to distribute that 1/2. Okay. So we'd end up with, let's see, 1/2 times 6 is 3. 1/2 times 8 is 4. So 3x plus 4 would be that one then. Vertical stretch, or vertical shrink, rather, of 1/2. Okay? So notice how both numbers in the equation are half as big now, right? Because it was a shrink by a factor of 1/2. So it all came down 1/2. Okay? So, vertical stuff, make sense? Take the equation, multiply by whatever the number is. Horizontal gets a little stickier, like the other ones. We're going to think substitutions again with these guys. All right, so with these, it's f of ax. So, do you see the difference between these two? What's the difference in how I'm doing it? Okay, it's multiplied in the parentheses, okay? Which means this one, the number that I'm going to multiply, is not in front of the whole equation like that one. It's just stuck to the x in the equation, okay? kind of like before with the translations and with the reflections, it's just the x. It's just on the inside on the x. Okay. Now for this one, just like with translations, remember how things are always backwards? If we saw a plus for a horizontal translation, it actually meant it was moving left. And if we saw a minus, it meant it was actually moving to the right. Same thing here. Okay. The number that you multiply that you would think would make it bigger actually makes it smaller, and vice versa. So in this case, if a is greater than 1, it doesn't stretch it, it shrinks it. And if a is less than 1, then you stretch. Okay, so I always just remembered, I didn't try to memorize all of these little rules when I was in Algebra 2. The way that I remembered it was, if it's anything horizontal, it's opposite of what you think is going to happen. Whether it's a translation, reflection, stretch or shrink, it's always the opposite is happening from what you would expect. Okay, so let's try that once then. So let's say I want, we'll do 3x plus 2 is our starting equation, and I want a horizontal stretch by a factor of 2. Okay, so if I want it to stretch, a needs to be less than 1. But what's my a? 2. All right, I want a horizontal stretch of 2. In the starting equation, it's 3. I get why you said that. But the number that I'm going to be multiplying in there is this 2, right? Because that's how much I want it to stretch. And so that's a little confusing because it's like, well, the number needs to be something smaller than 1, but yet you're telling me it's 2. So how in the world is that supposed to work? Well, to make that work, you're close. It's not negative. It's a fraction. You have to flip it into a fraction. You do the reciprocal, which means flip it, of whatever number you see. Yeah. It'd be a half in this case. Yep. So what we're going to do is we're going to replace x with 1/2 x. It's a substitution again, right? You're taking the x out and you're putting 1/2 x in. Okay? So we're going to have y equals 3 times 1/2 x plus 2. Okay? See how I just took away the x and then just dumped in there 1/2 x in place of it. All right, and we got a little bit of algebra to do there. I just got to do this multiplication right here. What's 3 times a half? 1.5, if you want to do it that way. 1.5, or 3/2, whatever you like the best. It doesn't matter to me, but just make sure you're doing that. So that would be the equation of that line with a horizontal stretch of 2. All right, so let's do a shrink, and then I think we're good to break into some little groups and practice this a little bit. So let's say we've got, we'll do an absolute value one here. Absolute value of let's do the absolute value of 2x plus 3, and let's do a horizontal shrink by a factor of 1/3. Okay, so again, if I want it to shrink, the number's supposed to be bigger than 1. However, I have a 1/3. So what number am I actually going to use for a then? 3, exactly. Okay, you flip the fraction again. So I'm going to replace x with 3x this time. Okay, so if I make that substitution, then I've got the absolute value of 2 times 3x plus 3. I just dumped it in there. Hey, what's up?
This is for the new girl.
She's right there. Thank you, sir. No, it's no problem. All right, so we got to do a little simplifying here, and we're all set, okay? So what's this going to be when we're done?
6x plus, no, the absolute value of 6x plus 3.
Yeah, absolute value of 6x plus 3. All right, so you've got all the little rules now that you need with these things, okay? Whether we're doing a translation, a reflection, or some kind of stretch or shrink, be it vertical or horizontal, okay? So it's kind of a lot to take in all at once, so I'm going to give you guys a chance to kind of practice it together here a little bit with some journal stuff. So I'm going to pause my recording, and if you guys want to take out your journals real quick, I'm going to let you know what we need to do here in just a second.